Friends, in our last video, we have gone through VBT theory very clearly. Through that VBT theory, we have analyzed the complex compound belongs to which are the categories. Through some tricks also we have followed. And in this session also some more examples we are going to go through which are very, very important. And weak field and strong field, as I mentioned, very few examples. So I just to bring it to your notice, which is very weak field, which is very strong field. I just to bring it to you like increasing order. So as you have seen this idea, you will come to know which are the weak field ligand, which are the strong field ligand. In that way, you can identify. Now, mainly will tell weak field ligand cannot pair up, but strong field ligand can pair up. Why I'm mentioning that is atomic orbital, it's filling that electrons, no, easily you can identify. So now let us go for that some more examples to find out what are the points to be noted. And one more thing, EAN also we are going to go through. What it is EAN? Effective atomic number. That is also in this session. Let us go and learn. Yeah, first and foremost, here FeCO5, NiCO4, you have to find out hybridization, magnetic property, complex, that is outer or inner complex, spin, higher or lower spin, and BM or magneton. So let us go and identify all this. The first one, that is FeCO5. Okay, Fe, it's a central metal ion. CO, it's a ligand. 5, it's a coordination number. And this is coordination sphere. Now, whom we have to identify? First and foremost, we have to find out the oxidation number. Whom we have to find out the oxidation number? Of course, central metal ion only. So, Fe. So, we can take it as X. Plus, ligand, it is actually 0. How many? 5. Equal to, there is no oxidation states. So, it's actually neutral. So, Fe, oxidation state, it is what it is? Neutral. Okay, now let us go and find out that electronic configuration. Fe, atomic number Z is equal to 26. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Fe, we can write it like this: Ar 4s2 3d6. Okay, actually Fe, it's a complex ion. This is actually a neutral, so no losing neither gaining electrons, right? Okay, now how to go for it? First and foremost, we have to prepare the empty orbitals, right? Now 3d6, 4s2, 4p0, 4d0. Okay, now in this, how many orbitals? 5, right? 1, 2, 3, 4, 5, and this s orbital 1, p orbital 3, and d orbital 5. 1, 2, 3, 4, 5. Okay, now here what it is? According to this, 1, 2, 3, 4, 5, and 6. Okay, now here actually 2 electrons are there. Okay, actually there is no losing electrons, neither gaining electrons as it is. Now we have to identify where do we go and fix the ligands. Now actually here ligand CO. Now you have to check it. Where is CO? CO, it is the last one. That means a strong field. A strong field can pair up the electron. So these 4 unpaired electrons and here 2 paired electrons. Let us pair the electrons together here. Now here what it is? 1, 2, 3. So 8 electrons are there, no? So 8 electrons we paired here. Now how many empty orbitals are there? According to that, how many coordination number you have to fill. Now here what it is? 5, no? That means here CO, 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 and CO. 3, 4, 5. Okay, so here it has to fill the pair of electrons. Ligands, electrons, right? It's sharing electron. So now easily we can identify what are the properties of this. Now this is actually what it is. DsP3. So hybridization what it is? DsP3. DsP3 hybridization. Whose DsP3 hybridization? FeCO5. And magnetic property. Is there any unpaired electrons are available? There is no unpaired electrons. So here just mention no unpaired electrons. Unpaired electrons. So no unpaired electrons means naturally it's a diamagnetic. Magnetic in nature. Okay, now D comes first. So that means it is a lower complex ion. Lower complex ion. The same way spin. Lower or higher spin? Naturally it's a lower spin. Lower spin. And Bm. Is there any unpaired electrons? See, root of n into n plus 2. N equal to what it is? Number of unpaired electrons. There is no unpaired electron. So Bm, it is nothing. 0. Right? Hope you're clear with it. Okay, now you found this one. Now let us go and analyze this. Right? Okay, the same idea. Let us go and follow to find out all these properties. Right? The next one, NiCO 4 times. So, which is the central metal ion? Of course, nickel. So, find out the oxidation number. So, X plus, of course, here what it is? CO, it's 0. So, 4 into 0. And there is no oxidation state. So, 0. So, actually, it's a neutral. Now, we have to find out the electronic configuration. So, nickel atomic number 28. So, here 1s2. 2s2, 2p6, 3s2, 3p6, 4s2, 3d8, right? 3d8. So we can write it what it is. Ar in the 4s2, 3d8. Okay, now let us go and fill the electronic configuration. So here for 4s2, 3d8, no, so here 3d8, 4s2. Now here, how to fill, whether it is paired or unpaired, already we have gone through such kind of compounds only, right? So it is carbonyl, it's a strong field ligand. It can pair up very easily. Strong people and all can adjust each and every place. The same way you can remember. So this is carbonyl compound which can adjust each and everything. So it can pair up the electron. So how many electrons are there? Naturally 5 electrons. And actually this is a neutral. There is no losing neither gaining electron. So now here itself let us fill it. So here how many electrons altogether? It's 8 plus 2, 10 electrons. So here itself let us fill. Right? So 10 electrons is over. Now how many empty orbitals are available according to that ligand? Here actually 4 ligands are there. So in that way you have to cooperate to fill the pair of electrons to that. So here what it is? CO, that is a ligand. 1, 4, no? CO and CO. So this ligand, pair of electrons which is contributing to the central metal ion. So here, so naturally what is this? sp3 hybridization. Hope you're clear. So what is that hybridization name? sp3 hybridization. Geometry. In our last video only I just mentioned all these tricks. sp3 or dsp2. So sp3 it is what it is? Tetrahedral. Tetrahedral. Okay. Now next one, magnetic property. Is there any unpaired electrons are there? No. There is no unpaired unpaired electron. So it's a diamagnetic. Magnetic. Okay, now complex. There is neither what it is. Actually, here it is not required for this series. Okay, now why? Because there is no d orbital empty, neither the side. So only sp3. That only we can go through. Okay, now what about this FeCO 5 times? What is its geometry? Here actually FeCO 5 times, this is DsP3, right? So DsP3, what is that hybridization? Trigonal bipyramidal. Last thing we forgot it, right? So trigonal bipyramidal. Hope you're clear with that all these ideas. Okay, now let us go and find out some more important examples which is relevant for the board exam. Some more important complex compound. Let us go and identify hybridization, geometry and magnetic property. Okay, first and foremost, MnCN6 4 minus. Let us find out the oxidation number. Mn, okay, X plus 6 into minus 1, that is a ligand, is equal to minus 4. So X minus 6 equal to minus 4. So X equal to plus 2 oxidation. So Mn 2 plus. Okay, electronic configuration we have to go now. So Mn atomic number Z is equal to 25. So we can write it 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Yes? Okay, now shall we write it like this? Ar 3d5, 4s2. Now you have to lose 2 electrons from the outermost orbital. Yes? So Mn2 plus. Mn2 plus is equal to Ar 3d5. Okay, electronic configuration we can draw 3d5, 4s0, 4p0, 4d0. We have to prepare the empty orbitals to fill the ligands, right? So first and foremost 3d 5 bromes will be there. 1 2 3 4. Yes, okay, here 3 and here 5. Okay, now let us fill the electrons here. Ligand, it can pair up or cannot pair up. Cn, it's a strong field ligand. So it can pair up that. So 5 electrons are there, no? Here, 1, 2, 3, 5 electrons. So these are all empty orbitals. How many ligands are there? Here 6. Coordination number 6. So here Cn, Cn and Cn, and here Cn. 6, right? Cn and right Cn. So 1, 2, 3, 4, 5, 6. 6 is there, no? So this has to fill the empty orbitals. That means it's sharing pair of electrons to the central metal ion. So this is now. What is the hybridization for this MnCN6? This is actually D2sp3. What is it? Hybridization. It's D2sp3. So D2sp3 means what it is? Octahedral geometry. It is octahedral. Right. Now next one, magnetic property. Magnetic property. How many unpaired electrons are there? Here one unpaired electron is available. So one unpaired electron is available means naturally it is what it is? Paramagnetic. Paramagnetic. So and Bm we can. So paramagnetic means Bm. What it is? Here root of n into n plus 2. Here unpaired electron 1 into 1 plus 2. So naturally here root 3. Hope you're clear with it. Okay, now let us go for the next one for that to identify. This is clear now? Shall I rub this? Okay, now the next one Fe H2O 6 times 3 plus. Okay, now here oxidation number X plus and 6. 6 into 0. This is neutral is equal to plus 3. Now X equal to plus 3 oxidation state only. Right? Okay. Now electronic configuration. So electronic configuration of Fe. What? Here 26, right? So 26 means 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Right? Okay. Now here, how do we write it? AR 3d6, 4s2. Now here Fe3 plus, no? Fe3 plus. Okay, now how many electrons it has to lose from the outermost orbital? 3 electrons. So that means AR 3d5 4s0. Right? Now electronic configuration for Fe. Okay, we'll rub because we'll get confused this. So Fe for this, here what it is? 3 plus only we can draw. So 3d5 4s0 4p0 4d0. Okay, now here what it is? 1 2 3 4 5, and this is 1 and this is 3 and this is 5. Okay, now we have to fill the electrons. Okay, it can pair up or cannot pair up. It cannot pair up. Now here 1 2 3 4 5. So cannot pair, no? Pair up. So automatically you will get that unpaired electrons only. Then what is the coordination number? 6. So 6 you have to fill here. H2O, H2O, H2O and H2O. 1 H2O and H2O. So here 1 2 4 5 and 6. So here actually what it is? sp3 d2. Right? sp3 d2. So now we have to identify what it is. Hybridization. sp3 d2 and geometry. What is it? Geometry. Octahedral complexes. Octahedral complex. Okay. D2 sp3 or sp3 d2 both are octahedral complexes. Magnetic property. Magnetic property. Is there unpaired electrons are there? Yes, it is unpaired electron. So magnetic property, it is a paramagnetic property. Magnetic property. Okay, Bm what it is? Bohr magneton. So here root of n into n plus 2. So here 5 into 5 plus 2. The root of 5 into 5 plus 2. What is the answer? Hope you can understand all these ideas. Okay, now let us go for the next one more point. Hope you are clear with these two sums and how to identify. I think you are able to identify other two also. Let me do it for you. Pause the video and check the answer. Next one, Fe, F6, 3 minus. So central metal ion, no? Here X. X plus 6 into minus 1 equal to minus 3. So that means X minus 6 equal to minus 3. So X equal to plus 3 oxidation state. So Fe3 plus, right? Now Fe atomic number It's 26. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Okay, now R gone. So we can write it 3d6, 4s2. Now Fe3 plus. How to write it? So 3 electrons you have to lose from the outermost orbital so that Ar 3d5. Okay, now let us go and draw the term electronic configuration to fill the ligand. Okay, now here 3d5, 4s0. Of course, you are losing that now. So 4s0, 4p0, and 4d0. You have to prepare the empty orbitals to fill the electrons of the ligand for that central metal ion. Okay, now here 1, 2, 3, 4, and 5. Here 1 room, and here 3, and here 5. Yes. Okay. Now this is can pair up or cannot pair up. F minus. So naturally it cannot pair up. So here actually one electron for each room, right? So that means here F, F, and F and F. How many 6 are there? 4, 5, and 6. So here, so you have to fill this now. Here, is it visible? So what is the hybridization here? Hybridization sp3d2. sp3d2. Hope you clear with this idea. Whether it is correct or not, you just check it easy. If you follow the tricks, it will be very easy. Okay, next geometry. Of course, geometry, it's a octahedral. Octahedral. Okay, now next one, magnetic property. As you see, unpaired electron only, it is what it is? Paramagnetic. Yes, I can hear your voice. Paramagnetic. Magnetic. Okay, now Bm. The same thing Bm also. So root of n into n plus 2. N it is what? Unpaired electron. So here how many unpaired electrons are there? 5 into 5 plus 2. Okay, so how many are there actually? Root of 35. So you have to. So they may give like this 35. Then how many unpaired electrons? Such kind of way they will ask you to identify. Hope you're clear with it. Okay, now we'll go for the next one more sum. That is also very easy. Fe H2O 6 times 2 plus. Now, how to identify? I'll write it here only. So Fe X plus here 6 into 0 equal to plus 2 oxidation state. X equal to plus 2. So central metal ion oxidation number plus 2. So Fe. Fe actually what it is? Ar 3d6 4s2. Right? Now here Fe2 plus. Fe2 plus how will you write it? Ar 3d6 4s2 because it has lost the 2 electron from the outermost orbital. Now, how to write the electronic configuration? Now, how to write it? 3d6, 4s0, 4p0, 4d0. Empty orbitals we have to fill now by the ligand. Okay, now here, how many electrons it has to fill? By the by, it can pair up or cannot pair up. Yes, it cannot pair up. 1, 2, 3, 4, 5, and 6. Here 6 electrons are there, no? Okay, anyway, it cannot pair up. So, ligands can fill from here only. So, here what it is? H2O, 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 and how many are there? 6 are there, no? H2O and H2O. So here 1, 2, 3, 4, 5, and 6. So six pair of electrons which will go and occupy for the empty orbitals to central metal ion. Okay, now what is that hybridization? Yes, P3D2. Now the same way here for this, that one, fourth one, here what it is, I just put it that different thing so that easily you can identify. So here what it is, hybridization, sp3d2, and geometry the same, octahedral, octahedral, and magnetic, of course it's a paramagnetic. Okay, Bohr magneton, what it is, root of n into n plus 2. So root of, it is what it is, 1, 2, 3, 4. 4 into 4 plus 2. Right? Hope you are clear with that. All these ideas. Now, let us go and check how do we identify EAN, that is effective atomic number. Now we are going to find out that effective atomic number of the following complex compound. Stepwise, let us go. Okay, FeCN6 4 minus. How to calculate that effective atomic number? Stepwise we will go. First step, you have to find out the oxidation number of this complex compound, that is central metal ion. So central metal ion, right? So X plus 6 into minus 1 equal to minus 4. So X minus 6 equal to minus 4. So X equal to plus 2 oxidation state. Okay, now plus 2 oxidation state. Now iron, Fe, atomic number of iron, it is 26. So Fe2 plus, right? So for this here 24 electrons are there. Central metal ion. Central metal ion. Now, ligands, how much it is giving? Cn, it's a ligand, no? How many electrons it can provide? Here, 6 into 2. So that means 12 electrons. Okay, now here, Fe2 plus that electron, central metal ion electron, and the ligand, these combined together, so 24 plus 12, so altogether this is 36 electrons. So that means 36 electrons means this is krypton, right? So in that way we have to calculate it. Hope you are clear with it. Now the next one, FeCO5 times. FeCO5 times oxidation number 0. So naturally, because it's a neutral ligand, right? Neutral complex. So here Fe only will be coming. In that central metal ion, how many electrons will be available? 26, as it is according to that atomic number. And because it's a neutral complex, okay? Now, how many ligands are there? 5, that is coordination number 5. So, how many electrons will be available? Electron gained by the ligand. So, that is 5 into 2, 10 electrons. It's a pair of electron now. So, that is 10 electrons. So, altogether it is 26 plus 10, 36 electrons. So, krypton electronic configuration. Now, next one, Zn NH3 4 times 2 plus. Okay, Zn, how to find out that what it is, oxidation number? So, X plus here what it is, 4 into 0 equal to plus 2. So, X equal to here plus 2 only. So, plus 2 means here atomic number of zinc, it is 30. So 30 and Zn2 plus, right? Zn2 plus. So Zn2 plus means naturally it is 28. Right? Now here how many? Coordination number 4. So 4 twos are 8. Here 8. So altogether what it is? 36. 28 plus 8, 36. Kr, krypton electronic configuration. I hope you got a clear idea about how to find out that effective atomic number of these complexes compound. Okay, now the last one here, what it is? Cu. Cn 4 times 3 minus. Okay, now you just to check it, pause the video and find the answer. CuCN 4 times 3 minus. So central metal ion X plus Cn minus 1, right? So 4 into minus 1 equal to minus 3. So X minus 4 equal to minus 3. So X equal to plus 1 oxidation state. Okay, atomic number of copper, it is 29. Now that means Cu plus. So that means Cu plus means one electron from the outermost orbital you have to lose. So that means here 28. So 28 here, how many electrons can contribute here? That is 4, no, 4 twos are 8. So here 28 plus 8, here also 36. So it is taking the krypton configuration. Hope you're clear with it. How to find out that effective atomic number. Okay, now next session, let us go and learn what it is crystal field theory. And there also some more sums are available. Let us go and learn. Okay, hope you're clear with it today, whatever we have gone through. Hope you got a clear idea. Thanks for watching. Please subscribe this channel and hit the bell icon so that you will get all the notification. Thanks for watching.